Welcome back to part 4 in this Dynakit ST70 restoration series. If you missed part 3, click on this link right here. We'll take you to it. In part 3, we installed the audio output transformers and wired them into the chassis. We also redid all of the existing wiring that was in the chassis using the new color code that was formulated for this installation. The electrolytic capacitor was removed from the old chassis. It was resurfaced and polished for aesthetics, brought to a shine, reinstalled into this new chassis, and then rewired into it. A second smoke test was done for the power transformer to ensure that everything would operate at full voltage. This was then followed by a test of the bias circuit, also running through adjustments of the pots to make sure that they were working properly. A look at the filtration of the bias was also conducted. And then a quick look at what was already installed in our DC power supply was accomplished, just so far as to see what it looks like on the output of the rectifier tube. In this video, we're going to continue on with the wiring of the chassis, all of the remaining wiring, as well as this front portion area here, which is an add-on. We're getting into some uncharted territory with this. We're going to be taking that circuit board off of the old chassis and mounting it in here and wiring that, completing the build-out process. So we have a lot to do this episode. Let's get started. So I wanted to kick off this next segment by pointing out something extremely dangerous with this particular amplifier. I'm going to do so by turning it on. I've got the voltmeter hooked up to the output of the rectifier. As I fire up that amp right now, let it warm up. Meter is set for 1500 volts. She's coming up on 560 volts now. This is what I'm going to do. I'm going to shut off the amp from the switch right here. And as I do that, I'm going to hit the start button on the stopwatch. And we're going to see how long this takes to drop down. Even at 10 minutes, it's still showing about 270 volts. 15 minutes after the amplifier was shut off, it's still packing a punch at 220 volts. 20 minutes later, and we're still at a possibly lethal 170 volts DC. 25 minutes later has us down to a finger zapping 140 volts. So it's taken 32 minutes for it to drop down to 100 volts. By 37 minutes, we're sitting at 80 volts. We're basically looking at 42 volts after 45 minutes. I just wanted to point out how exceedingly dangerous it is right now, sitting here with nothing to bleed off that electrolytic capacitor, that filter cap down there. So that concludes this. I thought people would find that interesting, how lethal these amps are, even after they're shut off and unplugged. So we're going to kick this off by extending the heater circuits on both sides off of the first tube that was already done. On this side it's brown, and I have some fabric-coated cable right here for which I'm going to do so. And it's going to extend from this tube socket to this tube socket, and I'm going to make a lead off of this tube socket, which is ultimately going to go to here. I don't know how exactly it's going to be connected yet. The other side right here, I will do the same, except that it'll be green. So the pigtails that make their way down to the sockets on the bottom are now finished. Temporarily put some holders to hold these wires together. I'll have a more permanent fixture here later. And now it is time once again to go back to the old chassis. And what we're going to be doing on the old chassis is pulling out the circuit board, PC3. I had done some work on it previously. I'll probably do some work on it again just to get the right color resistors in there. That's probably going to be for later though. The right values, right resistors, bring that in specification. Right now it's just about cutting it out, removing it, getting into new chassis, that's it. So here we go. The circuit board is removed from the old chassis, and this is not to say that this is the last of this old chassis. I may still need the 15.6 ohm resistors that are under here. We may see this old chassis again yet before we're finished with this project. But now we go back to the new one. And with that, we'll be putting the circuit board into the new chassis now. Took some time out to clean and polish the board. This is the result. I think it's actually Bakelite. Like it's a press sheet of Bakelite or the same chemicals they use in Bakelite, because that's the smell that comes off of it when you're actually doing the polishing. But I worked my way through there, got everything nice and polished, has a nice look to it now, a nice shine. So I'm going to be bringing the board around to the underside like this. Where we'll be then mounting it into the chassis. At this point, the board is now loosely fitted. We could set it up to be tightened down, having the front screws all aligned in the same position as all of the other screws on the front of the chassis. With that, the PCB is now affixed to the chassis. All of the screw heads are lined up. We're going to turn this over now and begin our wiring. We'll be starting first with our connections from the rear. They connect to the 16 ohm posts and they will make our way to the circuit board. We can see, looking at the diagram, the 16 ohm posts will make their way down to pins 12 and pins 13, and those are right over here, leaving the old wires in so I could keep a count of what hasn't been connected, lose track of them. So as I work on them, I'll take out these old wires, reflow the rest of them later. For these connections, I'm going to go with blue. And we'll remember that the 16 ohm connections are these special standoffs that we've added because they're no longer connected to the rear jacks. This is what these cables are going to connect to. So now the two connections from the 16 ohm taps of the transformer, they're now connected to terminals 13 and 16 on the PCB. Next is going to be the bias circuit coming off the two pots. They'll respectively go to the eyelets 6 and 21 on the PCB. This, of course, being biased means we're going to be using yellow. Now both bias potentiometers are connected to the PCB. Continuing our bias coming out of the PCB, we see pins 22, 23, 1 and 2. They go through a 1K resistor to each EL34 on pin 5, right? And in order to facilitate that, we're going to actually connect these cables to pin 6, which is unused. That will be connected to the 1K resistor, and that 1K resistor will be connected to pin 5, thus completing the circuit. So we're going to repeat that 4 times. Tested out 4 resistors here, and they were all within approximately the same value, so I'm going to install them now. As I'm installing this, I'm only going to be soldering down pin 5. Pin 6 will be waiting for the wires to be coming across from the board. Now have all 4 resistors in, waiting for solder on one side. Again, we'll be doing this entire process with the yellow colored cable. So the left channel is now completed. I will do the right channel. Bias circuit is now completed. We can see it coming from the transformer to the rectifier, comes through the filter, out of the filter. It comes into the potentiometers here, bridges across to the other potentiometer where it is adjusted, comes out of both potentiometers into the PCB. There is on both sides some resistors here cannot be seen. It's on the other side, comes out of those resistors, and on both sides comes out to their respective tubes through the resistors on each one into pin 5. mapped in yellow. I'm going to be hooking up now the high voltages off of this filter capacitor. Square, the one closest to me here, is going to be going to pin 19, and triangle here off to the left will be going to pin 20. This being part of the high voltage means we'll be using red. And there we go, the connections to 19 and 20 are now finished. I've also readjusted this. It's hard to see from this angle, but instead of curving inward into that connector, as this is unfiltered, I've brought it up and back and had the angle go this direction to keep a little bit of distance away from the filtered DC. Here's an overhead of those connections. We're going to be continuing on parts of the capacitive feedback circuit next. This is 11 and 14, and they're going to make their way to the tube sockets up front here on pins 4 respectively. The manual calls for the cables being as low to the chassis as possible as they make their way around and down, so we're going to do that. As part of that circuit, it will maintain the color blue. Now I have connections 11 and 14 are connected to pins 4 on both sides, pushed down close to the chassis as written in the documentation. We're doing pin 9 now. This is a ground, so it's going to be coming up and over to the star ground, and this is going to be green wire because it's a ground. As the wiring in this area is predominantly done, I'm going to take a minute and finally remove these non-lock washing nuts over here, put the correct ones on. I'm also going to dress those cables in finally to push them down with these that were removed from the old amp early on. It's important that none of the cables get impinged between the flat parts when tightening down. That's not what that's for. They should only be under here. I'll redress everything once this is tightened. I'm going to start working on these connections here for the input jacks and the mono stereo switch. I've tightened down these nuts here, and then I bent these tabs up, act as a sort of lock washer. The first thing I'm going to do is I've selected 2 brand new 470K resistors that I'm now going to put into the circuit. I'm only going to be soldering one end of each for the time being, as the instructions call for. There's going to be more than one thing connected to the other side of each. The first thing that's going to go in is going to be at this switch and going to this connection here. Put a hook at the resistor on the other side of the board, here up close, and I've adjusted it so this resistor passes through. It's going to have another hook on it to meet that resistor, making that connection. So we're going to see I'm going to put a hook there. I'm going to tie those off together. It comes through here. I'm going to solder off that ground. So now I have both resistors worked into the PCB. We can see this one goes from this switch through this ground and down. The other one we can see from the ground around and through the tip of this one. Still have a cable to bring across to the switch, and then both of the tips of these will be coming outbound to the board. We're going to go white for the input signals because we haven't used it yet. To start completing this action, I've tied on the first of these pigtails. I've just cut a length of white wire. And this channel right here, which is the left channel, will go to pin 7 right over here. First input's completed. I'll do the other side now. Now in this one, I was able to get 2 wires through the hole by reaming it slightly. I'm not going to be able to do that on this one. There's no way I'm getting 3 wires through the hole, especially when one is a resistor. I've left the length of cable to couple the other wire and then solder everything. This one will be going to pin 17 over here for this channel. So now I got the front jacks, and the mono stereo switch is now fully wired. The next phase of this project is going to be the bias balance control upgrade BBCU-1 Kit C for the ST70. We're going to be doing these instructions as dictated by this guide. It's one of the reasons that I have saved these connections here for last, why I've not continued my connections over here over to these sockets, because I figured there was going to be some sort of modification. Also why I've put in those other bias resistors onto here. I figured something was going to change. It was just better I leave it this way. Interesting note, we come to find that in step 2, it talks about removing all of those connections if they were in fact connected to this. So the sockets that would have been in this amplifier the connection to be removed from the sockets and where they were connected to on the board. Basically, what I have to do is simply remove these connections from the board. This also would have meant any connections that would have made their way up from the socket to the tubes, that continuing green cable that I would have in the original configuration wrapped from here over to the socket. Since I haven't done that work, there's nothing to do there. So now all of the old cables are removed from the PCB. Step number 3 would call for the removal of the old sockets and hardware. This has not been installed. Moving on to 4. We're going to mount the new ones in here. Pin 8 will be orientated to the bias set position, annotated on the outside. We're going to be using 440 standoffs on the inside. Only hand tightening, so I'm not going to be worrying about lining up the screws at this time. We're just going to get them in the right location. That's it. So here I have pin 8 pointed towards bias set, which is right here. So this will be the position for it. And I have my 2 standoffs right here. We'll be putting the screws to the front and tightening them in the standoffs. Again, this is just hand tighten. This is still loose. Again, identifying pin 8 pointing downward towards bias set. There we go. Sockets loosely fitted, installed, completed. The next instruction talks about taking a length of green wire and soldering it to pin 8 on the front sockets. This is what I have looked at on the schematic to be a ground. So green is fine. It talks about it being 2 inches, which means that it's probably going to be terminated up front here. I'm going to make a couple of changes to mine. I'm going to use my green wire because it is the gauge that I want, and I'm going to make that wire longer so it will meet my star ground on both sides. So I've just connected one side for now. By the time this is over, there's no sense in trying to connect one after the other. So now I have the grounds for both pin 8s make their way roughly up here, not fully dressed in, but close to the star ground. So we're going to do step 6 now with the balance pot and the circuit board. Calls for the removal of the nut and the washer. Then has the silk screen pointing outward and the alignment pin on the pot such that it goes in like this with the washer and the nut screwed back down and then tightened securely onto the circuit board. There's one completed. I'll repeat the process. There we go. Both are done. So now we're going to take one of the circuit boards we just assembled and we're going to put it through the socket in the front of the cabinet that we previously assembled, just like that, so that the 3 tabs from the potentiometer are pointed upward. We'll take one of our standard size screws and a lock washer, put it through the standoff and the hand, tighten it in. There we go. It's not tight, but it's on there. The step's now completed. Skipping the next step right quick, which deals with tying off these grounds. The jury's still out on how I'm going to handle that. And moving on to the locking down of these screws and centering this. So I'm going to temporarily turn this amp around so we can do the tie down procedure. We'll have to get the piece of paper again to center this hole. I use a lengthwise Dynakit brochure. It's a good stock to make the spacer that I need to center this. I just shorten it for exactly 2 wraps. Once I see 2 wraps go through, whatever folds over, I put a little notch right there and I cut that off. Get this in and around there. 2 wraps pretty much gets it centered, just like that. We're gonna have to slacken the rear screws a little to make sure we have enough to work with. We're gonna have to hold the standoffs to be able to tighten these and still get the screw heads pointed in the right direction. There's one completed. Going to do the other side in the same fashion. Make sure the socket was loose enough that it moves around. Perfect. With the sockets now centered and tightened down, I'm going to flip the amplifier back around so that I could tighten down the potentiometers that are in the middle. Those are already centered. I don't really have to worry about it. I just need to tighten down the screws. Nice and solid. Okay, so now both of these boards are tightened down and centered. Can move on to the next step. Step 10 says to ensure that all of these tabs should be 90 degrees as to not interfere with the top cover that'll be going on here. So I'll just do this quick inspection and bend these tabs down. There we go. That completes that task. And we've earned the right to turn the page. Next page starts back at step 1. These are ST70 specific instructions, and it talks about the removal of the 15.6 ohm bias resistor. I neglected to install that, thinking that I wouldn't need it, so I don't have to do that step. The next steps talk about the removal of the jumpers that go between V2 and V3, and V6 and V7. There's also a small jumper for each of those that goes between pins 1 and pin 8 on each respective tube socket. Now I got nothing installed, so I don't have any jumpers to remove, but you're supposed to retain that connection between pin 1 and pin 8 on each tube socket. So I actually have an installation that I have to do here. I'm going to do that installation now. For these jumpers, I'll just be using a non-insulated metal, going from pin to pin. So we can see I've stripped the wire away, fed it through 8, fed it through 1, and then put a little loop through 1 to hold it in place. Now I'll just solder it through 1, tie it off through 8, and solder it through 8. Do that 4 times. I've installed all those little tiny jumpers now from pins 1 and 8 on both sides. I can now continue with the instructions. Steps 2 and 3, both completed. Next, we're going to be reconnecting the filament voltage that used to come to this socket but no longer does. I'm going to be using black for this because I really don't have a color for the filament voltages other than the fabric-coated wire. I'm going to come off 7 and 2. On this side, it's going to be coming here to 15 and 16. These are going to be twisted wires since they're AC. And what I would like to do is come up and around, because it originally went to here and came down. So I'm going to come up and around, follow under here, and then come around and down, staying away from the circuit board until it hooks till the last second. So here's the first one installed, out of the way, up against the chassis, coming out here as far away from anything else as possible, and shooting straight down into the board. So now both connections come off this tube socket, which are pigtailed off this tube socket, which come from the transformer, making their way all the way through, and that completes the filament voltages. I came back and did some modification here. I want to talk about it. I used to have a ground wire come out of what here was pin 8, make its way all the way down. I've left them currently unconnected. The thing is, there's a lot of grounds that come off of this new system that terminate to ground from different locations, or terminate to a resistor that terminates to ground, like a pigtail, and it's difficult to just have resistors going directly to ground when you have a star ground, because you just have a floating resistor inlined to that ground. So what I've done was this. I connected that ground wire comes to the bottom of this circuit board. This circuit board has a trace going straight to up here where it continues outward, and I have that cable again. So it's just effectively a continuation of that cable. It provided for connectivity through that circuit board off of one of the pins up here. So it comes through here, through the circuit board, and connects to one of these unused pins. This allowed me to take a connection. There's a 1 meg ohm resistor that comes off of the center pot, and it goes down and meets that unused pin down there. Now, if the holes were big enough on the circuit board, I could have very well had the resistor come around and directly into the board. It isn't. So they're just tying off a meeting right over here. So this provides a ground to the circuit board, a ground from pin 8, basically meeting right here to this wire, and it's going to take it down to that star ground. So that takes care of the 2 grounds over here and the 2 grounds over here. Every one of these tube sockets now has a ground that comes directly off of one of the sockets to a resistor to ground. In keeping with the instructions, I should be removing the hardware on sockets 2 and 7, the inner side hardware, and replacing the star washer with one of these. It's like the one used over here, so that I'll be able to tie off the resistors to the ground. I would really like to run, though, from this a ground wire to my star ground if I'm going to do that. I'm going to have to recenter the socket before I tighten it. Got the paper in, and there's one connected. It's a ground, but it's also really kind of a standoff for the resistors. Now both sides have the tab on it. We'll continue. So I've pulled out the first of the 10 ohm resistors. I put a little piece of heat shrink around it, and I'm going to put it on pin 1 of V3. This is the top left, basically. And then I'm going to bring it down to this solder lug. And so I'm able to solder this in. I'm already adding this yellow pigtail. I'm going to deal with that later. The focus is only the resistor, but I know that this wire is going to be here, so I'm just hanging it off there. So now we have pin 1 making our way to the ground. We'll have the other one making its way to ground. This ground cable will make its way here as well, so we'll have one single ground wire where all these connected to, making their way to ground. Now I have both resistors connected with both pigtails. These remaining yellow wires now on one, I'm going to be connecting to the front octal sockets. This one's going to go up here. This one's going to go over here. This ground has now been cut short. Will be connected to these grounds and then connect onward to the main star ground. I have 2 more connections to do, and that's off the potentiometers. Those connections will come directly into pin 6. I used white up here just because there's way too much yellow. I know. It's just going from here to here. Kind of breaks up the colors a little bit. I think with that, this side of the amp is completed. There's nothing left to do except those grounds. Once the other ground is ready to go in, do it at one shot. So I'm going to do the other side of the amp now, just like this, bring this wiring to a conclusion. With the wiring now completed on this side, I'll now finish off the last 2 grounds to the main grounding point. Ground is wired, chassis wiring is completed. I'll just be straightening everything up, and that'll be it for this portion of the project. I'll just be tying up loose ends with lacy cord as necessary. The lacing of the amp is now complete. We could see that everything is a lot more rigid with the wires now interconnected with the lacing cord done on both sides where needed, mostly symmetrical. Also, this style of lacing was done here in a limited fashion on both sides. There's not a whole lot of need for this type of lacing, and there's no real bundles in the amp except for here and on the ground. And with that, this episode of this ST70 restoration comes to a close. When the next episode comes out, I will post a link for it up here. I hope you found this episode entertaining, helpful, enjoyable. Hope you learned something. Thanks for watching.
Thanks for watching. Would you like to reply?